Hi, in this week's lab, you're going to be building your own capacitor, measuring it, and comparing it to what you think its value should be. You're also going to be trying to calculate the dielectric coefficient of some materials that you're going to put between the two plates of your capacitor. First, I want to show you that the meters that you've been using are actually capable of measuring capacitance. And I'm going to show you that right here. All right, so this is the meter. You recognize it, hopefully. This here, this setting, this is ohms. And then you can see the parallel plates right next to the ohms. If I turn it there, that tells me it's going to measure capacitance. And the red plug, the black plug still goes in the common port, but the red plug will go into this port that has voltage, ohms, and it also has the little two parallel plates there. This meter is designed to measure capacitance. There we go. And just to show you that it actually measures it, I'm going to take one of the capacitors we used in a previous lab. This tiny little capacitor right here is supposed to be 1 microfarad capacitor. I'm going to hook it up to the probes here and see if that's something like what it measures. If so, we have some renewed confidence that this thing is actually doing what we're hoping it will do. So I'm going to put this here and here. Don't want them to touch because then it's going to be a short. And you can see here 0.969 microfarads, almost 1 microfarad. These capacitors aren't perfect. They're going to be within about 5% if you're pretty good. Sometimes maybe not quite 5%, but this one's within 5%, so we got our money's worth with this one. I'm also going to hook it up to a much larger one, not one that you used. This one's supposed to be 47 microfarads. It's much bigger. I happened to measure it earlier. I know it's not going to be exactly 47. It's a little bit more, but let's see what it shows us here. Takes a minute to readjust. About 49.45, something like that, microfarads. So it's a little bit bigger than what it was supposed to be, but on the order of 5% bigger. All right? So this is measuring capacitance. Now in this lab, I asked you, you're not going to be able to, you could do this at home, but you don't have a capacitance meter probably, but you can check and see. If so, then you're welcome to do this lab on your own. But if you don't, I ask you to cut 2 pieces of aluminum foil, 25 centimeter by 25 centimeter, and that's what I have here. Here's our parallel plates that we're going to create a parallel plate capacitor. And so I'm going to put, I say a piece of cardboard, I'm actually using a piece of foam board that I found, that I cut up. I'm going to put it in between them. This is going to function both to separate the aluminum foil by the thickness of the foam board, and it's also going to introduce some dielectric constant that I'll be calculating in just a few minutes. Or you'll be calculating, actually. I'm just going to measure the data, or collect the data, and you're going to use those data to try to make a measurement. So I'm going to hook up one probe of the meter to the lower part of the foil. Let me show you this. Can you see it? Pause this. All right, let me see if you were able to see this, at least to some degree. Looks like I think you are. There's my hand, okay. So what I did is I hooked up one probe to the bottom piece of foil. I put this piece of foam board on top of it. Then on top of that, I'm going to put the other piece of aluminum foil. That's the other plate of the capacitor. I'm going to hook the other side of the meter to that, like this. And then we're going to see what the meter tells us. Whoop. It's telling me about 0.24 nanofarads. I'm going to put a book on top of it. And you might ask, why am I going to put a book on top of it? It's to get the pieces of foil closer to each other. What would you expect the capacitance to be if I actually got them closer to each other without getting them to touch? Capacitance should go up a little bit. Notice that it went up to about 0.28 nanofarads. because I want the true spacing between the capacitors to be that piece of foam core. All right. Now what I'm going to ask you to do is to try to calculate the value of the capacitance, and you can use this equation. The capacitance is equal to epsilon 0 times A. Now A is the area of this plate, which remember is 25 centimeters by 25 centimeters. You have to convert it to meters to actually determine the area in square meters, because you need it in square meters. Divided by D. Now you don't know what D is. D is the thickness of this plate. Now what I did is I stacked 4 plates together. One of them is being used in the capacitor right now. And I measured the height, and I came up with 2 centimeters for 4 plates. So what does that mean for 1 plate? Given that, calculate what capacitance you would have if there were no dielectric if the dielectric constant were equal to 1. And then from that, you can determine what the dielectric constant should actually be equal to. That is your first task. Okay, now that you've done that, what I want you to think about is what happens if I double the dimensions here so that I have 50 centimeter long piece of foil underneath a 50 centimeter long by 25 centimeter piece of foam core with a 50 by 25 centimeter piece of foil on top of that. And I'm going to cover this with books so that I know that there's spacing is what it should be, but for the thickness of the foam core. And I'm going to measure the capacitance like I did earlier. Let's see what the value is. If you can see that, I'll make sure to tell you what it is, just in case you can't see it. Make sure the foil isn't touching itself or the other side. So if it is, capacitance would probably be 0. Okay, so now I'm getting something close to double what I had before, which is what I would have expected. But is it what you would calculate? See if you can figure that out. I'm getting about 0.45 nanofarads. Hopefully you can see that here. Okay, the next part of this problem asks me to double the thickness. I'm going to use 2 of these squares. Put a piece of foil here, and the other piece of foil on top, and determine the capacitance of this arrangement with double the thickness. What do you think it should be? Let's see if it comes out close to what you think. So one probe, actually I'll put this one on the bottom. Doesn't matter which probe I put on which side. And I'll put this one on the top. It certainly seems smaller than it had. And I'm going to put the book on top. We're at about 17 nanofarads, 18 nanofarads, something like that. May not be exactly what we thought, but it's relatively close, given everything, given all the uncertainties here. And actually, as I push it down, it goes up a little bit, maybe 19 nanofarads. Okay? I'm going to stop this video here. The next video is going to involve doing this with saran wrap and paper, but this is a start.